Okay, and welcome. Welcome to Digital Construction with BIM 360. My name's Steve Rudge. I'm Head of Construction at Excitech, but I'm also BIM Manager on the project and the case study we're going to go through today.
So I'm Caroline Shaw from Balfour Beatty. I'm BIM Coordinator on the RDD project in Manchester.
Right, so what we're going to do first is just quickly go through the project itself, just to give you a quick feeling of the size of it and the complexity of RDD itself. So the costs were in excess of 300 million. It's 78,000 metres squared. That's about 11 football pitches. It's a highly complex building because there's a lot of laboratories in there. There's a lot of lecture spaces. So the building services side is very complex. Looking at the numbers of students, 6,750 students are to be accommodated in this new university block, Manchester Engineering Campus Development, but we'll shorten it now to RDD. And it's the largest construction project undertaken by a higher education institute in the UK. Unfortunately, Gareth Spencer, who's the BIM manager for the university, has also got a speech at exactly the same time as we've got ours, so that was a bit unfortunate times. So, just to give you an idea of the site, is anybody aware of Manchester University? It's a huge site. I think it's the biggest university in the UK. And you can see the vast spans of the site, really. Quite large, but what we're looking at is a lot of these buildings over here on the top left-hand side. It's a bit fragmented as a campus. So RDD is looking at developing this area here, which is next to the Manchester Aquatic Centre. And it's that area, really, that we're putting 4 new buildings. So we've got Mech Hall, we've got Oddfellows Hall, we've got Upper Brook Street, and we've got York Street. And I'll explain as we go through them. But you can see there the list. They're the facilities that are being brought out of the old existing buildings and brought into this new facility as we go forward. Just to give you an idea of the project, I mean, I've been engaged with the university from back in about 2011. So it's before PAS 1192 was around. The university had some requirements and they wanted to put a digital focus on the delivery of this. They wanted to drive some of the BIM processes, but it was interesting because we were writing the EIRs before PAS was around and things like that. And obviously, during the design stages, we were looking at the technologies that were available. And again, I'll go into some of the details of that in a moment. And we're into construction now, so we've been into construction. The project award to Balfour's was last year, but we had an early engagement on the process. So around 2016, the construction and early works have been happening, and handover is towards the end of 2020. So this is just a video, really, to get you an idea of the project. The big black building right across the back there, that's Mech Hall. That's the large facility. The one in the front here is Upper Brook Street, and that's got a link bridge which goes between Mech Hall and that facility. This here is Oddfellows Hall, and you can see the dome area. That's a listed building, which we've got to obviously take care of, but there's an extension to that. And this is York Street. That's where the things like a lightning test, so we're bringing electrical equipment in and striking it with lightning and things like that to make sure it still functions after that. So that's really the site of the project. Great site to be working in, but as you can see, very congested, not much lay down areas, and we have to control things that are happening on the site itself. So as we're delivering, we have to think about the university requirements. And as I said, we helped them develop the EIR back in 2011, 2012 for the project. And in that, we had some key deliverables. They wanted to get things out of this project. They could see the vision for the digital side of working. We had level of details requirement because the university actually want to take control of these models after the project's finished. They wanted a clash resolve model, so it was actually quite accurate when they take over it to maintain the facilities going forward. But they wanted everything stored in their own CDE system, which was Conjet. So we had to consider that when we took on the project, etc. And they had some real requirements around space and asset management. It's a huge facility, as you can see, but it's how they manage that post-construction right the way through the life cycle going forward. And if I show you this complex model, this is the thought that we have to think about. As you can see around the top in the dotted box, this is what's going into the CDE area. This is basically the models that we're creating, and using Navisworks and bringing information in from the field on iPads and intelligent spreadsheets through the likes of ID8 BIM Link and things. We're capturing all this information, but in the end, it has to go into 2 university systems, Archibus for space management and Oracle for asset management. And that's the consideration we had to take right the way through the delivery of this. And obviously, we had to take risk, timesheet management, O&M, and asset registers, etc., going forward. So let's start looking at this model management side of things. You know, we can't just throw this at Revit, say, and Navisworks. We have to structure this job correctly, just due to the size of it. You know, there's 4 buildings in here, and you can see here, this is just the structure and M&E side. It's a very heavily populated building services buildings. And just to get that clash resolved was a task in itself, as you can imagine, but we've got there. And if you look at this from NG Bailey, you can see some of the things in here. There's over 12,000 luminaires. We've got 120 kilometres of conduit, 34 kilometres of trunking, etc. So you can see the amount of materials that's got to go in that building coordinated. And we spent weeks running clash detection meetings, getting it down to a reasonable level. But what's really worked is Balfour Beatty got an early appointment, and they brought in NG Bailey early as well. And what that allowed us to do was work as a fabricator who's going to install the building services to actually work with the design team who were Arup. And by working together, there was no real drop of information as it passed over. And what that meant was, when NG Bailey got on board, their design information was already in here. They were able to look at this model. It was fully coordinated. And as you can see off this slice through the model, the complexity of it was so important. And all this fabrication of data and that is coming from the design model. We've not had to go back redesigning things. And the importance of this is what NG Bailey are doing now is bringing this into modular construction. Because we've got confidence that all the services in the building will actually fit in now, we can take these, as you can see here, the frames on the left-hand side of the corridor. We just took the Arup model that Bailey's had worked with them on, and we're putting a steel frame around it, which is going off to their fabrication shop over in Bradford. And it's given us confidence that when these modules are delivered to site, that they will actually fit on the project itself. And you can see here, there's some more modules there, etc. So we have to make sure that the modules that we were bringing in could fit. And it was all done, really, through a manual process. Now, who uses Navisworks? Show of hands, quite a few of us. A few little problems with Navisworks. Great tool, great for clash detection, great for commenting, but when you work collaborative as a team, a few problems, okay? So this is the workflow that we had early doors, and it was just the technology that was around in those days. So we had NWC models out of Navisworks that the design teams actually populated into the CDE, which was Conjet. We then had to federate them into an NWF file in Navis, yeah, and keep these up to date. Now, obviously, to distribute that around, we can't distribute the NWF. We had to create an NWD file, which again was then uploaded for distribution on Conjet and the CDE. Then what happens? We have to comment on it. We have to start resolving clashes. And yes, the architect downloads it. Great. They can start working on it. But also, the M&E and the structures people download it. I've now got 3 versions of this model. Oh, and then the Manchester University downloaded it, and I downloaded it. I've now got 4 versions of this model. And I had to get 4 or 5 different comments from different companies, all back through XMLs, back into that original model. And if anyone's used Navisworks, you'll appreciate this, because you can't get, without getting in a team environment, allowing you to comment on that one model. And it was these XML files that allowed us to do it, but you can imagine the amount of work that we've had to go through on that project to get to there. So we didn't have a single source of the model, so it was a risk to us all, because I didn't know whether I collated all the comments and the clash detection resolved issues. I couldn't collate the comments. Some of them were missed, so it was a bit of a struggle. Approving clashes were problems, and manual federation, and we had to download these files all the time, so we were just passing big models around. So what we've done now is, once Balfour Beatty were appointed, we brought in BIM 360 Glue. And with BIM 360 Glue, what it's allowed us to do is look at a simplified process. And this simplified process allows us to simply get the design team to use the plugin of glue in the ribbon of the add-ins in Revit. By doing that, it automatically pushes it into Glue and federates their models for us. By doing that, we can still open the models, federated, and run the clashes still in Navisworks. But you can see how simplified that process is compared to what we had.
So, as Steve has just discussed, we've simplified that process by using the plugins. So it means that we've got it available on the Glue platform, which means the site team have access to it, we have access to it, the consultants, so all the design team are able to contribute using the Glue tools. So once we're happy, we can merge the models in Glue, and then export the NWD and upload it to fulfill our requirements by the university to have it on their CDE, which is Conject. So as you can see, this just illustrates some of the time saving we've had. Obviously, we've reduced risk because we've been able to allow one source of truth. So we're all contributing to the one area. And then you can see just by the time saving how beneficial it's been to the team. So overall, we're saving around 276 hours a year. So another issue we had was the RDD process, which has been an extremely, well, it's still ongoing, to be honest. So we've got over 2,000 rooms just in the Met Hall, which is a huge facility. And all of those spaces have different functionalities. They've got existing equipment that needs to go into each area. So all the controls have to be considered, the services, etc. So all parties are brought to one arena. We have a discussion, which is where that initial RDD meeting starts. So we have all the faculty, the end user, we have the client, we have the project managers, the consultants are all there, and Balfour Beatty, to discuss what the exact requirements are. So we decided we'd use an online cloud-based product, again, BIM 360 Docs, to eliminate any FTP sites that have been used internally or any other file transfer methods. So as you can see, we had, so Severfield are our frame subcontractors, so they were able to put their IFC files in. We had our structural, we had our architects, and our MEP models all going to the one area, which allowed us a quick turnaround. We also made use of the compare and view of the previous revisions on there, which was really beneficial, so you could see what changes had taken place in each of the rooms. And obviously this is the WIP area, so this is work in progress. So it's a quick turnaround, it's limited access to whoever's involved in the RDD, so no outside parties are involved. It's just purely an area which has got a quick turnaround. We're then able to download the Revit file as well, obviously from Docs.
So look at this in a bit more detail. Has anybody looked at the next generation of Docs and model coordination? Okay, so it's quite a new platform. And what the beauty of it was, because these files were actually being generated and developed so quickly, we were able to monitor the changes that the RDD process was happening. And by bringing the models in such a frequent timing, due to that process that we've established, we could actually see which walls have been modified. So there, and we can actually click on them, and it tells us exactly how much that wall's moved to see if it's got any impact on the modular design that NG Bailey were doing, etc. We could have a look at any additional doorways that we had to put in to get this existing equipment, because don't forget we had 8 facilities that were moving. So all the existing equipment that was coming from them facilities had to come back in to this new facility. So as part of the RDD process was that existing equipment was coming in, but we had to look at additional doorways and things as well. And also anything that's been removed.
Sorry.
So we need to check and look what we're ordering. so we don't over-order things as well. And just by doing it simply through this platform, it gave us a good, quick overview to actually see the changes. And it wasn't just in 3D, because as you upload to docs, you actually can compare 2D as well. So some of the details that may have changed by the processes, we can actually look and compare the 2D comparison as well, just to start looking at things. Now, we had another problem, because by uploading to docs in Revit files, and you open a Revit file in docs, you saw a single model. So you saw the architect's model, the structural model, but in isolation. So everybody was saying, well, this is happening so quickly, we need to start seeing the federated model. How do we do that? So this is where we added model coordination in, which again is the next generation of glue. And this allowed us to quickly upload the models, and the model federation was done automated. So by just uploading that model once, it refederated the model and gave us the option to pick which models we want to federate, so we can review just structures against services to make sure that there's no additional conflicts on coordination issues coming into the system, and it's quickly, easily, and processed well. And it gave us another added bonus, because by adding this model to the system itself, it gave us automated clash detection. But it wasn't going to replace what we're doing in Navisworks. It just showed us that by doing a design change or some design options, does it prevent or pose any additional problems on the project? And that's been proving quite useful, because we can quickly monitor the changes, the problems, and anything that's occurring as the design and that develops. And if any of you have used the next gen of glue, the model coordination module, it's the fact that, you know, if you've got one clash, so you might have moved a ceiling down, it's not counting that, as you can see on the screen, as 20 clashes. It's one clash, because by moving the ceiling down, it's obviously caught on the existing equipment in the room. So I only have to move the ceiling up to resolve that issue. I've not got to start working on 20 additional clashes and getting them resolved, etc.
Right, so field management, it's something that Balfour Beatty has really pushed. It's, the BIM 360 field is something we've really engaged with across all of our projects. But I'm just going to discuss what we've done on MECD. So these are the key points that we tried to cover. Obviously, we want to collate and improve our QA, so collate all of our health and safety, not all of ours, but our QA check sheets, react to any issues quickly and turn them around, increase productivity, so reduce the amount of time people are needed in the office, and also provide live construction information in the library.
Anybody using BIM 360 field? Yeah? Another problem, isn't there? The library. Okay? So we're talking about, as Caroline's just said, we needed up-to-date live documentation out in the field. We wanted it to be the latest version and have confidence that it was the latest version. If anyone's using BIM 360 Classic on a project at the moment, the problem is the library needs to be maintained manually. So you have to upload out of a CDE the additional files into the library of BIM 360 field. And this posed a problem to us, because we didn't have confidence that the site team were actually reading the right data. The version control wasn't there, etc. So,
yeah, so like I said previously, we wanted to reduce the risk, and obviously having live construction information, we considered what would we have to do? We'd have to get a person in place that would be sat there. We estimated about 27,000 drawings being produced for MECD. So obviously we couldn't have someone sat there just uploading drawings into field, because obviously we were managing the CDE as well. So our in-house IT team was set a project, and it was to automate whatever was changed. So these rules up here, so there's a file, we tried to follow PAS 1192, but obviously there were elements that the university contributed, so it's not strictly, but the elements that were pulled on, so we created an API and a web interface. And that basically would pull on the originator, it would file it in the originator's folder on the field library, the volume, so in which area that drawing was relating to in terms of the building, and then the series number, so the element code, so what particular works did that drawing detail. So what we were able to do was create a web interface linked to an API, which we could type in which originator, so as and when the subcontractors were coming onto site, we could put into the web interface exactly their 3-digit code. So this is all from our naming protocol, which is part of our BEP and our document control system. So we were able to put in the requirements. So I put in the contributor, the originator, the volume, and the series number. And automatically on the next run, which is done on, it's automatically run, so it appears in the library. And we've got a lovely structured library where all of the drawings are listed under their titles and all in the folder structure noted on this side here.
So by doing this, it really gave us confidence that the site team had the right documentation, it was stored in the right folder structure, and we knew it was the latest version that was uploaded as a conjet available to the people on site where it really matters.
So the only trigger, sorry Steve, was if as soon as that drawing was appointed a status, so it had to be, the purpose of issue would have to be construction, so it pulled on that rule, and then also once that status had been appointed to status A, it automatically pulled it through to field, which meant took all the human element out of it, which reduced obviously the risk of anyone working from old revisions, and they had it in electric form on the iPads.
So as we developed and implemented BIM 360 Field, we had to implement it in such a way that we consider what was happening on the site itself. It was no good implementing the full system and just throwing it at everybody with thousands of check sheets and quality and safety sheets in there. We had to think about what was happening. So one of the first things on site was bringing site plant and equipment on there and being able to check and monitor what was happening with that kit, because we have to do checks on it weekly, daily. We have to know whether it's on hire, off hire, where it is, all that good stuff. And traditionally it was all done in paper, but then we had to try and get that into a system somehow. So we looked at doing this digitally through BIM 360 Field, and this is what we did.
Yep, so obviously as Steve discussed, we had a number of large contractors, especially for the concrete elements. There were at one point 27 MUPs, we've had endless amounts of excavators, etc. So we use the equipment function on field in a slightly different way. So we appended a barcode to each piece of plant. So as soon as they were brought in, we do the check sheet on the field, we create a list of generic plant references on the equipment and listed them under the different types. And then as soon as the next piece came in, the guy that was signing, the site hand that was signing that piece of plant in would complete the checkpoints. So you'd have the check sheet and then a 360 photographs of the piece of plant, the serial number, and then the daily checks against it. So as the operator hands the check sheets back to the site manager, they would take a copy of that check sheet for that day. Also, we can mark on here whether it's been on hire or off hired, and the company is assigned to it. So it just means that we can tackle exactly where that plant is, so none goes missing. It means that we know whereabouts it's being used and what subcontractors, how many pieces of plant they have on site. It helps us monitor as well how long plant is on site, so how long it was anticipated to be on site and actually if it has fulfilled that. It also gives us great data for reporting, so we can look at the status and also, again, the duration. Another way we use QR codes, so again, under equipment. So obviously, barcodes in equipment tend to be assigned to an item or an asset. We thought, well, why not barcode a person? So hot work permits, we gave a high-vis badge, as you can see here, and permit to digs. So basically, it works as you assign the QR code, so we allocate a number of permits to a particular subcontractor, and then we assign the relevant check sheets, which is linked from our BMS. So we have a catalogue of our BMS check sheets available on our field system. And then we just assign the relevant check sheets to the particular QR code. We then also take a photo of the person using it. We assign the company as well, and obviously make sure we've got the relevant check sheets available, assigned to that particular QR code as it's issued. So anybody that's doing a check or is out on a tour can visually see that that person has been assigned a permit and has been accepted to go and work in that area and been checked. So this is just an example of someone obviously carrying out some hot works and being checked on site. And as you can see, the badge is very highly visible.
Now, we've already talked about check sheets. Now, BIM 360 has check sheets in it, but not suitable, a lot of them, for what we're actually doing as a main contractor. And what Balfour Beatty have done is spent a considerable amount of time building their own portfolio of checklists within the system for health and safety, for commissioning data, and for quality. But we've soon found a problem, because when we started to engage the supply chain, they said, well, that check sheet you're pushing onto us isn't what we use. We need our own checks in place. We need our own quality procedures in place. So we couldn't push just the Balfour Beatty check sheet onto that supply chain partner. What we had to do was start working with that partner and looking at what they had within their checklist and coming up with a project check sheet. It took time, but that was really so important, because then what it did, it got the subcontractor really engaged in the system. If we'd have just pushed our quality check sheets and safety check sheets, they would have probably have to do their own system as well, which becomes a lot of time-consuming effort on their behalf. So if you're looking at check sheets and considering check sheets, always consider the subcontractor, as well as, if you're a main contractor, your quality assignment as well.
Okay, so like Steve said, the key point to it is early engagement. So we included in all the orders with the subcontractors that they were to use Field, and they were to purchase an iPad, and that they would have a number of iPads to suit their team number. So Expanded have been doing the concrete elements to the job, the columns, the liner walls, and the basement, lots of other structures made from they're doing the cores as well. So at an early stage, we engaged with Expanded. They had a highly elite QA system they were already using, and we sat down and we went through on a number of occasions, which took a lot of time, just to review exactly what they were producing, what they would feel confident in leaving their QA checking on our system. So we collaborated both check sheets and ensured that we were both happy to move forward using the combined check sheet on Field. So what we did was we listed all of the concrete elements, very similar to what we did with the permits, under equipment. So we had concrete elements, and then we'd list them, so liner walls, columns, etc. And a relevant check sheet was then appended to those particular types of equipment. So pre and post concrete checks, etc. There was a number of others were assigned to each piece of equipment. So then it went on to the progress markups. So on the next slide, Steve. So we were able to identify by using our plans. So we had a number of reference plans that Expanded used, and they would mark up the pour number, the date, and then link the equipment to that particular pour. So we were then able to link all of that fantastic data, photographs, anything we could append to those check sheets, and trace back if there was ever any issues with any of those concrete items. Another way we've been utilising barcodes on MECD is for weekly hoarding checks. Obviously, we're right in the centre of Manchester. You know, we do tend to get damage to the hoarding. There is issues with hoarding sometimes. So we have a regular check which happens weekly. So this is Will. He is one of our graduate construction managers, and he is carrying out the weekly checks. So we've set up a task for Will. Every week he gets a notification to say, carry out your hoarding check. And on that barcode, he just scans the hoarding, and it links him back to the check sheet that he's to complete for that task.
I think what's key here is the bit of barcoding on the person's desk.
Yeah.
Because what you don't want is somebody coming out onto site and thinking, right, what am I doing today? Oh, it's a check sheet I've got to do. If they've got certain activities and tasks, we issue an A3 sheet of barcodes with their tasks on it.
Yeah.
So before they go out on site, scan it. It's all set up for them, the system. They go out and do their daily work, but the system's configuring itself just due to a barcode on the desk.
And all the plant as well is like that. There's a check sheet for all the plants with the barcodes on. So this is the next which is something we are engaging in at the moment, which is with our facade designers and manufacturers, Cipro, which are based in the Czech Republic. Now, they use a system called Track and Trace, which I'm sure you're all familiar with. It's a manufacturing, logistics, quality management tool, which monitors the panel from start on the production line all the way through to delivery. So we thought, what can we do with that? That panel's got a barcode appended to it, and when it's installed, that barcode's there. How can we utilize it? So we did. We get issued the detail of the barcode. We can then put that into field and append the relevant check sheets. Again, work with Cipro to make sure we've got a combined check sheet. And also we can manage the status, because as Steve mentioned, there's not a lot of room around MACD. We're very tightly restricted, so we can't have stillages sat with panels surrounding our site. So the idea is there'll be a number of generic panels and there'll be a number of bespoke panels which need to go in certain locations. But with the generic panels, if there was to be one that was damaged, we could, if it was safe and obviously the right run, we could put that panel in place. And obviously with this, we can mark the panel reference and the type. So that all comes on the barcode, which we can complete against the equipment. So we know we basically know what type of panel and how many we've got of them. Associated check sheets, so we're going to assign all the check sheets assigned to it. The logistics status as well, so we can know, as soon as it comes to site, it comes off Track and Trace. As long as it's not damaged and it's fully quality checked and everything's been handed over to us, we can then utilize that barcode through the installation. So we can do any snags on it. We can add it to a location, so we can add it to an elevation, so it's easier to trace that panel. And then the appearance profile, which is something that you've been working on, Steve.
So by using that existing barcode on that assembly of the curtain wall paneling, we were able to configure BIM 360 to capture the full data of that panel. And some of the data that's being captured live in the field is the fact that signatures capture date and time. So we knew exactly what was happening. So if something was being delivered to site, by just adding a signature to it, we've captured when that asset was delivered to site. We've got status codes, so we knew what was happening with that panel when it was actually on site. And that's all fed back through the BIM 360 link into Navisworks. And what that's allowed us to do is start monitoring graphically in Navisworks where each panel is. So the green ones are actually in situ, they're fixed in place, no issues. The blue ones are on site, ready to be put in place. The yellow one is going to be delivered within the next 7 days. The red one is it was damaged and it's now been sent back. So we've got a potential problem and risk there, because if we're trying to seal a certain area for fit out, etc., we know we need another one of them panels ASAP on site so we can carry on with the fit out and weather sealing within the building itself.
So navigation viewpoints. So this is something we have lots of engagement with the university and the community, and also our team. We're constantly having visits on site because it's quite it's a massive project. So on site, what we've done is created viewpoints in the model on field where you can actually navigate to the model view from where you're standing. So this just marks on the plan. This is myself just standing here demonstrating how we can check progress. So we can actually look at the model and see where we are with the frame and the core, and obviously the basement. This is on the right-hand side. So it's a great tool to look at where we are productively, if we're going to have any issues, and just give people visibility of what the project will look like, what the building's going to look like, and what it's going to look like in terms of surrounding buildings, etc.
So by actually using that process, we started to think, well, if we can place ourselves around the externals of the building, let's put ourselves in the building, and let's start looking at each room individually as an asset and putting a barcode against each room. But you can imagine just Met Calls over 2,000 rooms. How do we put that into field? So what we've actually done is wrote a Dynamo script which reads the room space that's put into Revit. It picks the center of the room up and the room name itself. And the Dynamo script simply places a 3D bit of text in that room. So when we scan the barcode, it's actually linked to the text. So it takes us and navigates us to each room individually from the barcode. We can then start using the gyro functionality to check the services that have been placed in there, any equipment that's going on, any services or anything that's happening in that space itself. And that's helping everybody, because you can imagine trying to navigate yourself around 7 floors of a building, 2 basements, all in a model fully PPE'd up. It's impossible. So by the use of barcodes, that's now helping everybody on site to get full functionality and use of all the digital information that's being captured through Revit, the model, and things of that nature. And again, it's just from the power of just using that barcode.
Right, so this has been a great addition to MECD. It's an information box. So it's a 32-inch touchscreen information centre, basically. So this has been a focal point as an information hub, really, for the site team and the operatives. So we tend to hold our site briefings around it. It also offers, if we're doing health or safety briefings, it's a great tool to use visually of any issues that we're incurring in a particular area. It also gives us links to the 360 suite, so we're able to look at the 3D data and the 2D, live drawings, and also it's got printing facilities, so it's a great help.
So obviously no one always walks around with an iPad. Yeah, so what these are, it's an information centre you can actually go to. So if you've got a group of people around you and you want some information at your fingertips, you don't have to go back to the site hut to go and either get your iPad or some paper drawings. The idea is you can come straight to here, see the information live, because it's on 360, it's linked up to that, and we can actually get to that data instantly and give team briefings, etc. So, useful bit of...
And it's on wheels as well, so it gets moved around into the areas in which, obviously, we're concentrating on, so it's great.
So I started the presentation really talking about the university's information requirements, and I think all of us that have been engaged in BIM, it's a real asset to the client to get this right. And obviously, I said before, we've got these 2 systems, Archibus and Oracle, and we have the information defined to us what they use in those systems. So in this instance, we didn't need the likes of Kobe because we had a full structured information delivery. They gave us a list of all the assets they wanted. They gave us a list of the information that's needed against those assets, and also what they were using for space management as well. So if we quickly look at the space side of things, what we've done is Revit has now linked truly to Archibus. So the space data the architect's placing in there and the commissioning data that we'll capture through the 360 field is linking directly to Archibus. That's what they use for their space management system. If they update anything in Archibus now, it will actually go and update the data in Revit. So as an estates management team, that's a nice now workflow, and they can see use of this model going forward as we hand it over to them. Whereas before, they had to go and trace around each of the room spaces in 2D to capture the size of the rooms and the functionality of the room. And just by using a simple workflow and working with the APIs of Archibus, we've now actually got this working. On the asset management side, we've got Oracle. Again, we have to collate the data to suit their requirements. Now, at the moment, there's no direct link to Oracle, so we've had to use Excel sheets. But the beauty is them Excel sheets aren't dumb Excel sheets. We're using something called ID8 BIM Link. And what that's doing is allowing us to strip the information out of the asset with the holes in it that have got the commissioning data in, and getting the supply chain, the manufacturers to fill in that data that we need, such as serial numbers, model numbers, and etc. that the university are going to need during that maintenance period. And it's that commissioning data that we need as it's being fitted out. If you've got 10 fan coil units being delivered to site, how do you know which one's going where? You've got to capture the serial number. If every one of them's different, and if it tends to site, how do you know which one's going? And this is really how we started to structure this, because we had to put a classification system on everything. So we could start defining what was going to be modelled, so we could attach data to it, to what level of detail that asset needs to be modelled at, so you can see the 300, 350, and does it need information requirements added to it that suits the university. And by going through this with NG Bailey, we actually then started to see what and how we capture that information, again by assigning a barcode to that asset. So when someone's going to install it on site, they scan it, and the data that's in the list is the data that the university needs. And that's all going to be audited at the end of the day because we have to hand this over to suit their requirements. But we had it fully defined exactly what they wanted and how we're going to pass it to them. And by doing it this way, we knew that the information was being captured at the source. We knew the information was direct to the asset, because of the commissioning data that was being brought back. And by doing it and capturing it in BIM 360 field, we could round trip it and actually get it back into the model if it was a Revit file. So we knew that we had that single source of truth again. We didn't have separate systems flying around. We knew that the Revit model was capturing the information that we were capturing in the BIM 360 field platform, and we could see it in Navisworks, etc. as well. So wherever we clicked that asset, in whatever environment that we were in, we could see the right data that was needed. And we also knew that all that data we were capturing was going to help us deliver this O&M that we've got to do in 18 months, 12, 24 months' time, etc. And like I said, this information we're capturing, we've got to verify it. We've got to come up with a system that we actually audit. And we have to think of geometry and have to think of information, two important bits of information that needs to go into that model. So on the information side, we've just simply created BIM interoperability tools. Everyone aware of that? Yeah, BIMinteroperabilitytools.com. Some great free tools from Autodesk there that will allow you to get into the models, run a little coding, and I can do it so it's not complex coding. Get in there and run simple checks against information and the state and condition of the model. And you can see there, I mean, this one's 83%. It's not off MECD, but you can see what's happening there. And these checks are run regularly. So I know the condition of these models as they're coming in, how much information we need to start capturing on it.
So with regards to geometry as well, virtual building, so we hold a lot of BIM meetings with the model up on screen. Also the site team as well, because they've got access to glue, they're able to go around the model themselves and be aware of what issues they're going to have in certain areas. Clash detection, so we have a clash detection review meeting as well, again where we visually see. Now, just to make you aware, these aren't Balfour Beatty issues, they're just examples of what we're trying to avoid. So yeah, they're not on any Balfour Beatty projects. So yeah, these are examples, classic, these are things that we need to avoid. They're just...
If we end up with one of them on this job, then I'm walking. Because
I am too.
All good stuff. So what we've got to do, because of the processes we're putting in place, we've got to change the way we're working on site. We've got to get away from this first come, first served that actually happens on a day-to-day traditional build. We can't afford for that cable tray fit-out guy to come on site and put his tray where he wants, and then the piping guys and put that in, then the ducting guys, oh, that'll do, I'll put it there. We can't afford to do it. We've got to make sure that what's happening on site is actually correct to the model. And its accuracy is coming more and more important. We've got to progressively monitor how this building is going to be put together, how it's being built currently. If things are out of place, we need to know, because these module elements that are coming back from NG Bailey and the services side, they've got to fit when they get to site. We can't afford them to clash at all. And what we're doing is introducing something called Verity. So what Verity is basically verifying everything that's been built on site. And how it works is you basically load the model up of the elements that you're trying to check. So here we've got a steel frame. We also, in Navis, load up a scan of that frame. And the laser scan and the model sit on top of each other, as you can see. Then we can select elements that we want to analyze. So here I'm going to select all the columns, and I want to check if the columns are in place. And after the analysis, you can see you get a color representation. So you can see on this again isn't MECD, it's just an example. You've got 3 red columns. They have been installed out of tolerance. They've been installed outside of 20 millimeters. Now that could be a problem, okay? But I'm aware of it, and I can adjust and monitor what I need to do and how I need to get around that before I get the elements and modules to site, which are going to cause me a problem. Now, we have done this on the basement, as Caroline said, that big area that you saw at the side of the core, and everything has been installed at the moment in the basement to within 10 millimeters. Mm-hmm. And that's really great
Revit,
example
isn't it?
of what Expanded have done for us.
Yeah.
But we've got good confidence now that when we start pushing the building services modules into that area, it will actually work. And these are some of the reports that you can get out of Verity. You know, it'll actually tell you how far a column's out. If there's any deflection in a beam or something like that, where the deflection may cause you a coordination issue, etc. But it's just to be aware that this technology is around, because we're now using it to make sure that everything we bring onto site will actually fit.
So, utilising field for as-built verification, because obviously it's not always, you're not always able to scan an area. There might be an issue with timing, so it might be temporary works that you can't get to. Cost, obviously you can't afford for your scanning team to always be there or have someone trained up to do the scanning. And access, it might be a restricted area, so you can't fully get the scanner set up, you can't get the surveying equipment set up to actually carry out the scan. So we found the gyro, a really handy tool where we can gyro and have a look at the actual model and just check that everything is as it should be in the model. So this is just an example of the two grids. If you can see the two lightings, this is, again, it's not MACD, but just an example. You can see on the model, and then on the actual, you can see that that's been, the lighting and the grid have been put in two rather than the single. So that would have to be changed in the model to rectify what's been done. So, benefits. So the benefits we have gained by collating all that rich data from site is that we can look at it on a dashboard, an analytical dashboard, to report to see the project health as an overview. So we can see if there's any issues or any kind of risks that we're going to face or anything that we can prohibit to stop from happening. So that's a brilliant tool for us to feed all that data into and have all of our systems talking to the one area. Key points, so things we've learned through this process really is get the project team to buy into it. So release it in a structured manner. Don't try and force them into it straight away. Kind of directly look at what we're doing on site at that point in time and feed into it in a timely manner. Work as a team. So we have a weekly drop-in. So we say any issues you've got on the field, BIM 360, or any BIM issues you've got, drop in and see us. We're there. Any issues you've got as subcontractors, site team, anybody can come to us and we can help resolve any issues. So that will be anyone that's got issues with check sheets, locations, if they're trying to find their way around the model, we're there for them as a point of support. Again, that's probably where that happens, listen to problems and look for solutions. So we're always willing to work around, hence the early collaboration with the subcontractors. We want to accommodate them. We don't want it to be a hindrance, so hence why if we all agree, and if there's implements put in place, then that won't ever happen. Don't be afraid of change. So again, that's something that people are always afraid of change, but if you do it in a structured manner like we have, they've engaged, they've opened, they've really found a benefit from using the BIM 360 package. Define and document the procedures. So we have a number of documents set up on how to use field, how to use glue, and also how we use it. So it details all of our processes internally.
Like I say, it's bringing everyone on your journey.
Yeah.
I mean, what you can't do is just push something, all this digital side of things, onto a team across every supply chain partner like that. We have to work with them all. Mm-hmm. And that's what's been hard work, isn't it, really, is getting everyone on board, getting everyone's buy-in, getting everybody to put the system in place that's going to suit them as well as Balfour Beatty. And I think that's been a big challenge, but once people have engaged in the new systems, they've seen that actually it's no different to what I'm doing now. No. It's actually better. It's saving me time. I'm not going to go and fill that paper in and then try and record it and store it somewhere. I'm just doing it once in the system, and it's capturing it right, and it's fulfilling not just what they need to do, but also it's covering what Balfour's need out of the system.
So these are some statements from key members that use field out on site, just to pick up on a few of the points. So proactively manage QA on site. There's a few here. Reduces the amount of paper if it's set up right from the beginning. Stress reduce, we all welcome that. So potentially could save on cost overall. Reducing time spent in the office, which is a big thing. Improve on quality assurance. So there's some really good feedback from key members of the team that actually are fully engaged with field and glue on site.
So hopefully that's give you an indication of what we're doing on the MECD project. And really it's been focused around these 4 products. And it's really proven that digital construction is a way forward. And it's took me and Caroline sort of 2 years to get where we are, but it's been a gradual process. We've not just sat in a room for 2 weeks and said, this is what we'll do and implement it. We've done it gradually. We've brought the system on a journey, and we've brought it on a journey with everybody that's on that project. And I think if anybody takes anything away from this, that's what we need to do. Work with everybody, implement a system in a way that we'll all engage with it. Work in a system that will give everybody benefits. Don't just look at yourselves if you're a main contractor. Work with the teams. Let it work for them. If you get it working for the supply chain partners, they'll engage with it. They'll start using it. And I think that's when we can start seeing some of the benefits and some of the processes that we've put in place here, really. So we've got about 4 minutes left. If there's any questions off anybody.
And wait for the microphone. Yeah, the ladies over here with the microphone. Got a guy. Oh.
Excellent presentation. I'm impressed by what I see today. I have 2 questions. One is how you deal. I show quite a lot of integration between trade disciplines and design and construction. But how information go back? What I mean, if you found something on a site and you need to redesign. Right. So, yeah, go ahead, sorry.
So in the 360 field platform, when you've got the iPad out on site, you can raise an issue directly.
Yeah.
So there's lots of just standard features of BIM 360 field. So what happens is if anybody's on the site, they've got full access to raise an issue. And what will happen is you raise an issue and you can scan the nearest barcode and it'll locate you where you actually are. But then what you do, as soon as you hit issue, you can drop a pin directly onto a floor plan. So if you can spot a snag or a problem or a health and safety issue or whatever it may be, the pin is dropped onto that 2D floor plan to directly point you where the issue is raised, so it's and then assigned to a person to rectify it or raise it as a health and safety issue.
And then that gets issued out to them, so they get a snippet of where that pin is placed, and then a detail of what that issue is. So also the client will come out and do issues as well. So we have the TA. They come out and do checks via field, and also the client themselves will come out and do visuals, so they can raise issues, NCRs, there's snags, there's defects, so there's lots of functionality there.
Maybe not complete question, but maybe what I mean is if you need to go back and design it and go back in same way and install it, so it's whole process. It's not identify a snag and you just rectify the snag, which is construction snag. Someone not did design as install as per design, but you need to go back. Sometimes you have a site.
So you mean redesign an issue, a problem that you may have found on site, etc.
So they're captured in the review meetings. So
there's 2 areas here, because first of all, when we're scanning things, if we find a problem, we'll either have to bring that back into the model and redesign the model to make sure there's no issues with any of the services or coordinated assets around that area, and that'll start working as a workflow. The other area is if we find we need to design something, we have to go right back to the beginning of the process, redesign it in Revit, run it through all the clash detection, review process, bring it through a coordination meeting again, and then approve it for construction. You know, so we can't just make a change on the fly. It has to go back to that design partner who's managing it and bring it right the way through the process from stage 1, really, right the way for construction again.
And I can see the tools are good at discipline or trade integration, but tools are not better in integrating information within a discipline. So my schematic doesn't talk yet to my 3D model. I'm M&E engineer, sorry, by trade.
Good M&E.
So my schematic is my key design.
Yeah, I mean, basically the system's open. So whatever information you'd like in the model into the field system, we can actually get it in there. Because as you bring the model through glue into field, this is classic version, by the way, bringing Revit through glue into field, we can map what data you actually want to see while you're out on site. And then the forms itself can capture the commissioning data that you want to bring back into the model for your life cycle records and as-built record, really.
say, as you did for the detail link back to the drawing.
Yes.
Yeah.
So it's a full life cycle.
So that
You
is
can map it back to Revit or
schematics, which has an input into your design, which is model, and also linked to your schedule.
Right, so we can link a system. Yeah. It probably gives anybody else a chance. If you want to come and see us on the stand, we'll have a good chat, because it sounds as though there's some great discussion to have. So let's have a chat later. Anybody else? Just of course your time's gone now. So.
Hi Steve, James Dixon from Wait.
Hello,
Great
sir.
presentation. Thank you for that. Quick one.
Yeah.
Flash management.
Yes.
On one of your earlier slides. Are they being auto-identified within the model, or is it something with search sets?
We're doing search sets
Yeah.
within traditional Navisworks,
Okay.
but we started it with a high tolerance of 200 mil to get the numbers down of the big things where the bits of big plant was hitting columns and all that good stuff. Then we reduced it to 125 mil and then 75 mil at the end of design.
And then we looked in areas, didn't we? So areas that we were currently working in, we would do a clash purely in that area as well.
Yeah, because we don't want to clash detect things
prioritise.
on the plant room roof.
Yeah,
when
we're all
actually the basement's
coordinating in
being
the
fitted
basement.
out.
Okay. So it's search sets within Navisworks.
Search
Yeah.
sets in Navis, but when we got that new process going, we're using next-gen glue just to monitor that by introducing a change, it wasn't going to present an extra 300 clashes, because we got the numbers right down.
Great. Thanks.
Okay, so, sorry, come over to the Excitech stand and we'll have a good chat. Sorry, we're just out of time, so please come and see us both. We'll be over at the stand just over there, so.
Thank you.